Hello everyone, welcome to the fourth lecture for chapter pair of linear equations. So in our past lectures we have looked at the graphical methods we can use to solve a pair of linear equations. Now the graphical methods work very well in case we have solutions as an integers and you can exactly locate at the points in the graph to find out the intersecting point, their exact values. But in the case where the solutions are something, let's say 12 by 5 or root under 3, root under 7, something like that, some irrational numbers, then then it is difficult to plot exactly, to find exactly those points in the graph. So a better way to solve these types of situations are using algebraic methods. So there are namely three different methods that we'll look into: substitution method, elimination method, and cross multiplication method. So we'll first begin with substitution method, and so this we will learn directly through examples. So let us have a look at our first example today. We have two linear equations. The first one is 7x minus 15y is equal to 2. The second one is x plus 2y is equal to 3. Okay, so now in substitution method, the first step that we do is step 1. We just take one of the linear equations among these two and represent one variable in terms of other. So here equation 2 looks quite simple. So we just represent x in terms of y. So x is equal to 3 minus 2y. This is our step 1. Now in step 2, you just substitute x in the other equations. You represented one variable in terms of other. Now you just substitute it in the other equation. So 7x is 3 minus 2y, and we have minus 15y. This will be equal to 2. And now we'll just solve this. 21 minus 14y minus 15y is equal to 2. So we have 14, 15, 29 minus 29y is equal to minus 19. Therefore, we have y as 19 by 29. And now we are already into step 3. So in step 3, we substitute this value back into this equation. Let's say this equation as equation number 3. So we have x as 3 minus 2y. Therefore, we have x as 3 minus 2 multiplied by 19 by 29. So now we just do 3, 29 minus 2, 19, divide by 29. So you have equal to 49 by 29. So we have our solution here. X is equal to 49 by 29 and y is equal to 19 by 29. So this method is as simple as this. We start with step 1, represent one variable in terms of other. In step 2, we just substitute this variable into the other equation and then solve for that variable. And in step 3, we put this value back into the equation we got in step 1, and we solve for the other variable and we get our unknown values for x and y. Okay, let us have a look at another example. So what do we have here? Aftab tells his daughter, 7 years ago I was 7 times as old as you were then. Also 3 years from now I shall be 3 times as old as you will be. So there is something going on with the ages. So there is Aftab talking to his daughter, and we need to figure out Aftab's age and daughter age. So first thing we do is write our variables. What do they represent? So the first unknown we have is Aftab's age. Let's say it is x. The second one is his daughter's age, and let's say that as y. Now let's just put what he's saying in mathematical terms. So 7 years ago I was. If we have to write this, then we will write it as 7 years ago. If Aftab's age right now is X, let's say is 35 or something, then 7 years ago his age would be 35 minus 7 or X minus 7. 7 years ago I was 7 times. 7 years ago I was 7 times as old as you were then. So Aftab is saying 7 years ago I was 7 times as old as you were then. So 7 years ago his daughter was also y minus 7 age. So now this is our first equation. 7x minus 7 is equal to 7y minus 49. So we say it as x minus 7y minus 7 plus 49 would be 42. So we have our first equation. Now let's say what is going on in the second part. Also 3 years from now, 3 years from now I shall be. So after we saying 3 years from now I shall be. So after 3 years from now, which is x plus 3, I shall be 3 times. Shall be 3 times as old as you will be. So 3 years from now I shall be as 3 times as old as you will be. So after 3 years, Aftab's daughter will be y plus 3. So 3 years from now I shall be 3 times as old as you will be. So this is our second equation. X plus 3 is equal to 3y plus 9. Therefore this implies x minus 3y minus 6 is equal to 0. So this is our equation 2. Okay, let us just write here. Okay, so this is the pair of linear equation that we need to solve. Let us solve it using substitution method that we just learned. So the very first step is we represent x 3y plus 6. So we used equation 2 to represent x in terms of y. Now in step 2, what do? We put this value of x into equation 1. So x is 3y plus 6 and we have minus 7y plus 42 is equal to 0. So this will imply minus 4y is equal to minus 48 and cancel this, so you get it as 12. So y is equal to 12. And what do we do now in step 3? We substitute the value of y into this equation. So x is equal to 3 times 12 plus 6. So it will be 36 plus 6, 42. So we have arrived at our solution. So the final value that we got is Aftab is equal to x is equal to 42 years, whereas his daughter's age, which we assumed as y, to be equal to 12 years. So that's it. Let us just verify it. So 7 years ago Aftab age would be 42 minus 7, 35. 7 times as old as you were then. So 7 years ago Aftab was 35, his daughter was 5. So 35 is 7 times 5. So the first equation is satisfied. 7 years ago Aftab was 7 times as old as his daughter. 3 years from now Aftab age will be 45, his daughter's age will be 15. 45 is 3 times 15. So 3 years from now Aftab's age will be 3 times his daughter. So it satisfies the given information, and we have a solution. Okay, let us consider this example again. We had seen this example earlier. So we have cost of one pencil as x, one eraser as y, two pencil and three eraser, 2x plus 3y cost 9, four pencil and six eraser, 4x plus 6y is 18. So let us try to solve this using substitution method. So step 1, let us use equation 1. X is equal to 9 minus 3y by 2. This is our x in terms of y, and we substitute this in other equation. 4 into 9 minus 3y by 2 plus 6y is equal to 18. So let's say 2. So we have 18 minus 6y plus 6y is equal to 18. And what do we get? 18 is equal to 18. So this was our step 1. And at the end of step 2, we get a statement. We get a true statement. True statement. So what do we do now? Our y is gone. So we just get a true statement. What does this mean? This means that there is no particular value of x and y which will satisfy. There is not just one value of x and y which will satisfy this equation. So what we had seen earlier is these two lines are coincident line, and there are infinitely many solutions. In fact, if you just multiply this equation by 2, you get the other equation. So if at step 2 you get something like this, you get a statement which is always true. So from this we can we can conclude that this pair of linear equations are dependent and they will have infinitely many solutions. So the thing that we had seen graphically, we can observe here when we substitute the value. So let us also have a look at our rail example that we had. So the two equation that we have is x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. So what do we do in the first step? We represent x in terms of y, 4 minus 2y. Now what do? We substitute this in equation 2. So we get 2, 4 minus 2y plus 4y minus 12 equal to 0. This will give you 8 minus 4y plus 4y minus 12 equal to 0. So minus 4 equal to 0. So what do we get? We get an incorrect statement. What does this mean? This means that there is no solution for this pair of linear equation. And as we had represented earlier, that these two lines are indeed parallel, and there will be no particular solution. So basically, through these last two examples, what I wanted to show was if at the end of step 2 we get an incorrect statement, it means that there is no one solution. There is no solution for this pair of linear equations, and they are parallel lines, or they are inconsistent. And if at the end of step 2 we get something like this, a true statement which is always true, then this is a case of coincident lines, or these are dependent pair of linear equations. Okay, so to put everything formally into words, what we did in the very first step, what we do is you take either one of the variables, either x or y, and represent it in terms of other, whichever is convenient to do. In step 2, we substitute this value of y or x, whatever you have represented, in the other equation, and we just solve for that value. So if you, let's say, substituted x in terms of y, then you solve for y. If you substituted y in terms of x, then you solve for x. Sometimes what happens is you get something like a true statement, as we saw 18 is equal to 18. From there, we can conclude that the pair of linear equations has infinitely many solutions. They are dependent pair of linear equations. If the statement that we get is false, then the pair of linear equations is inconsistent. They are parallel lines and there is no solution. Whereas when we get a proper value for one of the variables, then we just substitute this variable into the other equation and find the value of other variable. And this is called substitution method, since we are substituting one variable for the other. Thank you.